All right, we're back and we're into word problem number 3 now. So let's go ahead and get started. A salad contains ham and chicken. There are at most 6 pounds of ham and chicken in the salad. Write and graph a system of inequalities to represent the situation. So again, as stated before, when we're solving inequalities with word problems, we need to identify what x and y will be. So in this problem, taking a look here, let me just do this again in yellow. The two things that we have in this problem that are identified are ham and chicken. And we're talking about pounds of ham and chicken. So we're going to say let x be the number, whoops, let's redo that. I got to undo. And let's make that a whole lot thinner, thank you. Let x be the number of pounds of ham. And let y be the number of pounds of chicken. All right, so we have x and y identified, and now let's figure out our two topics. So in this problem, we are talking about there are at most 6 pounds of ham and chicken, so that is the total number of pounds, so that would be one of our first inequalities. And of course, we can't have negative pounds of ham and chicken, so let's go ahead and say x has to be greater than or equal to 0, and y has to be greater than or equal to 0. And x plus y, and at most, oops, let me undo that. At most, there are 6 pounds of ham and chicken, so we can have less than 6 pounds of chicken, ham and chicken, or up to 6 pounds of ham and chicken. So we're going to say x plus y is greater than or is less than or equal to 6, excuse me here. And then the other topic we need to identify in our problem is it says that, well, actually we don't have any other topics. It just says there are at most 6 pounds of ham and chicken in the salad. So we have a really basic situation here. So this is our inequalities, and we just have to get it into a graphable type problem. So we don't have to mess with the x's and y are greater than or equal to 0, but we do need to alter this guy a little bit. And if you change it up, you will get something like y is less than or equal to negative x plus 6. And of course, what we will be graphing in our problem here is the following. And I'll do that in the light green again. So we'll say x is greater than or equal to 0. We'll say y is greater than or equal to 0. And we will graph the line y is less than or equal to negative x plus 6. So on our next slide, again, I've written out the system of inequalities for us, and we just have to put this in our graph. So drawing this out, and I'm going to make this a little thicker for the x and y axes. Remember, the line x is equal to 0 is actually the y-axis, so we will be graphing that guy. So hopefully I can make my line nice and straight like I did last time. That's not too bad. And so we're going to be saying we are going to say x is greater than, so on our graph we will be shading towards the right. And then of course with the y-axis, that is the line y, or the x-axis, that is the line y is equal to 0. And so we will be also shading above that. And I'm just going to shade that with a slightly different shade of green, I guess. Okay, so there's our nice area there. And this, of course, goes on forever. And then we need to do y is less than or equal to negative x plus 6. So I will plot 6 because that's our y-intercept there. And I'm going to actually make this thicker. Let's see, let's try this guy this time. There we go, I like that. So let's just aim a little bit better. There we go. And then we go down 1 over 1. I'll plot that point. Down 1 over 1, down 1 over 1, and so on and so forth. And we will be graphing that line. And again, that will be a solid line because it is including the negative x plus 6. So I'm going to connect those dots, hopefully not messing this up too bad, and include arrows because that line does go forever in both directions. And And of course, since this is saying y is less than this quantity over here, we want to shade below. So I'm going to pick a new color and I make it blue. I think blue will be my final answer. And of course, the final answer is where the underneath here, where everything will have shaded before, and that's the extra crispy region, if you've ever taken Algebra 1 with me. So I'm going to be shading all of that in there. And that's actually going to be the solution to that inequality, because all those points, all those infinite number of points that are contained within this blue region are the ones that would satisfy our constraints, our system of inequalities that we've set up here. So hopefully that helps. Next problem. Word problem number 4, it says Mary babysits for $4 per hour. She also works as a tutor for $10 per hour. So right away I see there are two things that have been identified. She's got two jobs, babysitting and tutoring. So those are going to be our X's and Y's. And so in our problem here, I'm going to say let X, and again, since this is a job, we'll be working in terms of hours. So let X equal number of hours babysitting. And let Y be the number of hours tutoring. And by the way, guys, tutoring is a pretty sweet gig. You can make some pretty good money doing that. So it doesn't have to be in math. If you have other skills in other classes, I would certainly investigate becoming a tutor. After we read that now, it says that she is only allowed to work 13 hours per week, and she wants to make at least $60. So those are two topics here, or two things that we're going to have to create inequalities for, is the total number of hours and the total amount of money. So again, we're going to go and write this out. And remember, X and Y are hours, so we cannot have negative hours. So we're going to say X is greater than or equal to 0, and Y is greater than or equal to 0. And then we also know that she can only work 13 hours per week. So X plus Y can be no more than 13 hours. She can work up to 13 hours. She can work less than 13 hours, but she can't work more than 13 hours. And then, of course, she wants to make at least $60. So if she babysits $4 times the number of hours babysitting plus $10 times the number of hours tutoring, that is going to be at least or greater than or equal to 60. And so we have our system now. So if I take a look here, we have our system written out here. But again, we want to graph this system. So I'm going to make these inequalities graphable. And again, I trust that you can handle the math on your own. But again, if you need some help, please see your teacher. And we're going to say that for this guy, Y will end up being less than or equal to negative X plus 13. And for this guy, if you graph this correctly, you're going to get Y is greater than or equal to negative 2 over 5, because what you'll get is 4 over 10. That simplifies to 2 over 5. X, and let me scoot this over a little bit more, plus 6. Okay, so when we graph our system of inequalities, and again, I'll start with green, we're going to be graphing the X is greater than or equal to 0, Y is greater than or equal to 0. We'll also graph this guy, Y is less than or equal to negative X plus 13, and also graph Y is greater than or equal to negative 2/5 X plus 6. And so we'll take it to the graph now. And again, I've typed out, let me undo that. I've typed out the whole inequalities for us there. And I provided a graph accordingly. And so we're going to graph this guy. And again, I want to shift it so it's a little bit more user-friendly. And we're going to say X is greater than or equal to 0. So here's our line, X is 0. Here's our line, whoops, let me undo that because that's going to, I can't see my numbers anymore. Maybe not quite that big. There we go. So we'll do this. Good enough. And this for the y is greater than or equal to 0. And I missed again. Let me try again. Whoop. That's better. Okay, and then we're going to be shading above and to the right of those lines. Okay, in general, that's just going to be our first quadrant. And then for this line here, this y is less than or equal to negative x plus 13. Now I'll go ahead and switch to a much bolder line. No, I don't want to stop recording. Here's our y-intercept is 13. And then I'll go down 1 over 1, down 1 over 1, down 1 over 1, and so on and so forth. You know what? I don't like those. I'm going to erase that and try not quite so thick. Let me go back and put the highlights in. And let's see. We'll do this guy. Down 1 over 1. Oh, missed. Down 1. You guys have no idea how frustrating it is to try to graph on the iPad. And we will get a line. Let's see. Doop. We will get a line that looks approximately like this. Okay, give or take. Yours will probably look much prettier. And this says y is less than, so we'll be shading below that. So I'm going to shade with pink. Like that, okay. And then for the next one, it says y is greater than or oh, I think I screwed up there. Let's check our graphs. Yeah, this should be y is greater than or equal to negative 2/5 x plus 6. So we're going to have to change that real quick. Mistakes do happen. So we'll just make sure we cross that off and say greater than or equal to. And we are going to go ahead and plot that. So here's 6 right there. And then we'll go down 2 over 1, 2, 3, 4, 5. Down 2 over 1, 2, 3, 4, 5. And then we'll be plotting that line. Okay. And we want the greater than, so that's actually going to be above. And as always, we are looking for the regions that have already been shaded that match. So our extra crispy area will actually be in here. So there we go. That is our system of inequalities for that particular problem. Now we do have a little bit further to go here, okay? And we're going to be getting into linear programming in the next video. But again, because I don't want to cut off in the middle of an example, we are going to go ahead and do a part 3 video. So I apologize for so many videos, but I really need to make sure you guys have all this information. So stay tuned for part 3.